2017 connected particles question. We are told there's a smooth wedge of mass 4m, slope b, it rests on a smooth horizontal surface. Particle of mass m is placed on the smooth inclined face of the wedge. The system is released from rest. Show on separate diagrams the forces acting on both. Well, we'll do that first. So if we look at the wedge, we have it's 4m, so we have 4mg. We have a reactionary force between the particle and the wedge called R. We have another reactionary force between the wedge and the surface that it's moving on. We'll call that S. We're not going to need it. We have our angle beta. And we have our acceleration. Did they tell us what the acceleration is? Kp cos beta. And that's in that direction. My particle, come across here, my particle m, so I have mg going directly down, I have beta here, and in here, so I have adjacent to beta, mg cos beta, and I should probably give that a dotted line, give this a dotted line. That a dotted line to be consistent. I have going this way mg sine beta, and the acceleration going down relative to the wedge, which is important in this question, is p. So the key in these questions is the acceleration of that particle, and I have my r going in this way. So let's look at the accelerations before we go any further. So if I take the particle, I'll do a big line here. There's p coming down this way, but the wedge is moving this way. What was it? Kp cos beta. So we have a beta in here, a beta in here. So this one here, this is my right angle. And I will need the acceleration going in this way when we're dealing with this direction, or going against mg cos beta. We'll need this acceleration here. That's opposite beta, so it's going to be kp cos beta sine beta is going to be the acceleration we'll require there. And this one here along this side here is adjacent to beta, so it's going to be kp cos beta obviously kp cos squared beta. And because it's p moving down in this way, the overall acceleration here is going to be p minus kp cos squared beta. So just keep a note of these accelerations for when we're now doing the forces equations. So if we start with the particle, since we have it here, let's look at this direction first. This guy, so it's mg sine beta, F equals ma. So mg sine beta is equal to m. And what do we say the acceleration was? P minus this guy, P minus kp cos squared beta. P minus kp cos squared beta. So that's the first equation for my particle. And that was going in this way. So the next one are up and down here, these up and down directions. So it's not jumping off the surface. So we're going to start with mg cos beta. It's not going in the direction of r. So mg cos beta, what else have we got going on there? We have mg cos beta minus r. And then it's equal to m times the acceleration going up and down, we said was this guy here. So it's m times kp cos beta sine beta. So a lot of causes and sines in this question, which will continue going down to try and solve it. It's a little bit awkward, but we'll get there. Okay, do the diagram for the wedge. So wedge, we know it's moving in this direction, so we need to get the force going in that direction. So we have our or coming straight down. We have our beta inside, and we're looking for the force going this way. So it has to be opposite beta. It's going to be or sine beta. Or sine beta. That's the only force, and that's equal to m times a. And we're told the acceleration is kp cos beta. Just double check that again. Kp cos beta. And the m of this one is 4m. So 4m by kp cos beta. So where do we go from here? So it's best to eliminate or. So we can use this or we could say or down here is equal to this guy over sine beta, the guy on the right over sine beta. I think it might be easier to use this one. So mg cos beta minus the other one, which is mkp cos beta sine beta, is equal to or. And then if we replace this or down here with that, we're going to get some crazy equation that we may be able to solve. And what are we looking for here? The value of k. The value of k, right? Just keep that in mind. We're looking for k equals. So let's replace that or with mg cos beta minus mkp cos beta sine beta. That's or, and we'd have to multiply that by sine beta, this sine beta. And that's going to be equal to 4mkp cos beta. So you just have to be patient with these questions. Normally a sine squared and a cos squared appears, and if it doesn't, we probably try and get one in there to try and help us simplify it down. Now, what does every term have? Every term has a cos beta. We can see that. So we should be able to cancel off these cos betas. These three. Does every term have an m? It does. Okay, so let's just rewrite that out again, but with multiplying this sine beta by what we have. So we have this g is all that's left here, g sine beta minus kp. Now here's my sine squared beta appearing. Sine squared beta is equal to 4kp. Okay, we're making progress. So let's see, can we get a cos squared in here? Okay, I said to you keep an idea of what we're looking for. K equals. Now we have a k here and we have a k here, but we've no k in this term. So if we can get a k into that term, possibly with a cos squared, we should be able to then start factorizing with cos squared and sine squared and simplifying down. And if I look up here, we're looking for g sine beta. This is the only one that jumps out at me as g sine beta. So actually you can cancel my m's here, divide across by m, and I get g sine beta is equal to p minus kp cos squared beta, which does two things for me. It gives me a k and it gives me a cos squared. So we're going to replace this one with p minus kp cos squared beta. And I also have a minus kp sine squared beta. So you see I'm going to be able to divide by kp here. Sine squared beta equals 4kp. So I could definitely divide by kp. That's really going to help us. They're gone with those and those. So I'm left with p. Now I can factor out p out of here and here. So p, if I factor it out, would leave me with or minus p. I've just made a mistake here. I've divided three things by kp, so I actually need to divide this one by kp. Just saw that. So that's going to give me a 1 over k there, which wouldn't help me. So let me go back and not cancel those kp's. Let me divide by p. That'd be better, wouldn't it? So if I divide by p, I'm going to get a 1 minus k cos squared beta minus, I'm dividing by p, k times sine squared beta, and that will be equal to 4k, because I want to keep those k's. Now I can factor out, I can say 1 minus k times cos squared beta plus sine squared beta equals 4k. So we should now be able to get down to what k is, because we know that this guy is equal to 1. So we have 1 minus k is equal to 4k, which leaves us with 1 is equal to 5k. So we'll get k to be 1 over 5. So be careful, and if you can identify that you're making a mistake, just really change it quickly, because in these questions it's so easy to go wrong. So in part 3 we're asked, show that p is equal to 49 sine beta over 4 plus sine squared beta. Part 3. Show p is equal to 49 sine beta over 4 plus sine squared beta. Okay, where do we start this one? So let's just have a look back up. I think again this one will help us, the one we used a while ago. We have g sine beta equals something in terms of p, and we're looking for p. So let's use this one and see what will help us. G sine beta is equal to p minus k. Now we have k, so we're going to change that now. K p cos squared beta, and again you can see the answer here just has sine in it, so we can replace this cos squared with sine with the formula cos squared beta plus sine squared beta is equal to 1. We should be able to simplify this down. Where's that 49 coming from? Okay, we don't have any 49s in here, but let's think about this 49. G we have here is 9.8, and 5 of them, isn't that 49? That's 49. So it looks like that where the 49 might come from. So g sine beta, and actually maybe this is where this 5 is going to come in, isn't it? G sine beta is equal to p minus 1 over 5, which is this k, times p cos squared beta. And if we multiply by 5, we're going to get that 5g that we were looking for. So 5g sine beta is equal to 5p minus p cos squared beta. Now cos squared beta plus sine squared beta is equal to 1. So cos squared beta is equal to 1 minus sine squared beta. So let's replace this guy with 1 minus sine squared beta, and we're going to get 49 here. 49 sine beta is equal to 5p minus p times 1 minus sine squared beta. And if we multiply out this bracket, we're going to get 5p minus p plus p sine squared beta. So we need to isolate the p. We're looking for p equals, so 49 sine beta, which is what we're looking for on top, is equal to 4p plus p times sine squared beta. So take the p out, and we're going to get 4 plus sine squared beta, which is what we're looking for on the bottom. So just tidy it up, and we'll have the solution. We're going to get p is equal to 49 sine beta divided by 4 plus sine squared beta. So a tricky enough kind of trig identity type question within connected particles. Just practice this question. If something like this comes up in the exam and you've practiced it, you'll have a big smile on your face. But if you haven't practiced it, the smile will not be a smile.